or if we go to week number 6 and we click on experiment number 6, that's the specific heat experiment, online experiment. Okay, so you don't have to do any physical experiment at home. It's all virtual, but it has several parts. The experiment again is all the questions will be multiple choice. So make sure first you follow the procedure, answer the question, the procedure. Then you can open the experiment. Of course, the way to open it is to click on the link, and then it will start the assessment or the quiz. Click begin, and you can see here the questions. You have around 20 questions that you need to answer. But first, let's download the procedure. I'll go with you over the procedure here. So you need to click on the click here link to download the procedure. And let me share with you here the procedure part. Okay, so this is the experiment here. It has several parts, okay, guys, so you need to be ready. Many of the parts are videos that you need to watch. Other parts are simulation that you need to play with. So it will have several links. The first link here, it starts with hypothesis. So you need to answer those 2 questions. You need to predict what will happen if you heat a balloon using any type of heating source like a candle here, any open flame. Then also what will happen if you fill the balloon partially with water. So before you inflate it, you partially fill it with water, then you inflate the balloon and subject it to the heat. So first, before you watch the video, you have the video here that shows you what will happen. You need to answer the question. You need to predict hypothesis. This is the hypothesis part. You need to predict what will happen and why. Okay. And again, the answers are multiple choice, so you have to select the right choice. And by the way, question 1 and 2 have 0 credit, meaning if you got them wrong, that's fine, because those are prediction. So don't worry if you got them wrong. They have 0 credit, but you have to answer them, okay? You have to answer them, but they have 0 credit. Then after that, you'll watch the video and see what will happen. So you'll click on this link. So that's the first part here, the video over the balloons. The second part is also another video that tests thermal conductivity and thermal insulation. The first part is also, you see the effect of water. Water, of course, has high specific heat. When you're subjecting a material like rubber, balloon is made of rubber, to heat, what will be the effect of the high specific heat water on the heat exchange? And the second link here, also a video that you need to watch. And after you watch the video, you need to answer the questions here. You'll place 2 beads on different spoons. One spoon is made of plastic, the other made of wood, and the third one is made of metal. And you need to see which bead will fall first. Here you have butter at the end of the spoon, and then you attach the bead to the butter. Of course, when the butter melts, the bead will fall. So which bead will fall first? Okay, and then you need to answer the question. So that's part 2. Part 3 also is a video about figuring out the specific heat of specific material, cadmium. Okay, so it's an experiment devised to be able to figure out specific heat, to calculate the specific heat. So you watch the experiment. First, you'll see that they'll place the metal in boiling water. Then after that, when the temperature reaches 100 degrees Celsius, they move the material from the boiling water to a cold water placed in an insulator, a styrofoam cup, basically an insulator. And using a thermometer, you'll measure the temperature of the water after you add the material to it, and you'll determine the initial temperature and the final temperature of both water and the material. Okay, and from that, you'll calculate the specific heat. So the video will go over that, but my questions are more focused on the effect of heat on temperature. For example, why the water only changed from 20 to 25 degrees Celsius, just 3 degrees Celsius, while the material temperature dropped from 100 to 25, which is 75 degrees Celsius. So why the temperature of the water only changed by 3 degrees, while the metal temperature changed rapidly by 75 degrees? Why? Okay, and we know that has to do with the specific heat value, right? Object that has low specific heat have a very sensitive temperature. The temperature change rapidly with the heat exchange. Okay, so the answer will be revolving around the concept of specific heat. And then part 4 will involve this simulation here, FET simulation. And let me share with you here this simulation so that you see what we'll be doing. And again, to open any link here, guys, you'll click on the control press, and then you'll click on the link. Okay, so you click on when you open the link, you click on the intro. You can see a thermometer, and you have different material, oil, olive oil, and you'll see that the specific heat of water is more than 2 times the specific heat of olive oil. Okay, water has twice the specific heat, meaning it's twice the thermal insulator of olive oil. Okay, you need to click on the energy symbol. The energy symbol will tell you about the heat capacity. And the good thing about olive oil and water, they almost have the same density. Water density is around 1 gram per cubic centimeter. Olive oil is 0.92. And since they have the same volume, so they have the same mass. Okay, when you have the same density and the same volume, the mass will be the same. So the mass is a constant here. It's not a factor for heating. We know the heat depends on mass times specific heat times the change in the temperature. We are isolating the mass, and also will be isolating the temperature by clicking on the link heater here. This means that they will heat at the same rate. Pick up a thermometer and place it on each one here. And then you can heat them together since the heater is linked. If you heat one of them, the other will heat at the same rate. So here we'll be heating them, and you can see the olive oil is rising faster. The temperature of the olive oil is rising faster. Why? Because the olive oil has what? Has lower specific heat, right? Olive oil has lower specific heat. So its temperature is more sensitive to the heat exchange. Specific heat is actually less than one half the specific heat of water. So its temperature will rise faster, although we are giving them the same amount of heat. Okay, we are giving them the same amount of heat. If you cool them, the same thing here. Olive oil will cool faster than water. The temperature will cool faster. So you'll be doing those experiments here and answering the questions over that. And make sure to read all the steps in the procedure, guys. Okay, all the steps. So here I showed you the screenshots of what you'll be doing.